The first question says, prove that sine to the power 4 theta minus cos to the power 4 theta is equal to 1 minus 2 cos square theta. Now here, to prove this particular question, we are going to use the algebraic identity. How did I understand here? You are going to understand this shortly. Let me show you this one. We know that x square minus y square is equal to x plus y into x minus y. Here, if you look at the LHS first, which is sine to the power 4 theta minus cos to the power 4 theta. Can this be written in the form of x square minus y square form? Let's think of it. Look at this, x square minus y square. So here, to satisfy this given situation, here I need to write sine square theta, because sine square theta and you have a square above, so it becomes sine to the power 4 theta. Similarly, to satisfy this, I am going to write cos square theta. Again, square and square become power of 4. So you understand here the x value is sine square theta as well as y value is cos square theta. You know that x square minus y square can be written as x plus y into x minus y. Writing the same over here. So we are going to write x plus y. X value is sine square theta plus y value is cos square theta. Here we have x minus y. X value is sine square theta minus y value is cos square theta. Now here comes the most important point. You already know about the trigonometry identities, and from here it is very evident that you know sine square theta plus cos square theta is equal to 1. This is the first square identity that we have known. So writing this out, this become 1, and here you are left out with sine square theta minus cos square theta. Now if you look at the right hand side, it says us to prove 1 minus 2 cos square theta. So from here it is quite evident that we need to keep cos square theta. We cannot eliminate cos square theta because it is there in the proof. But if you look at sine square theta is absent in the to proof statement. So somehow we need to eliminate sine square theta. Now again you look at the square identity. How do I eliminate sine square theta? You know that keeping the sine square theta at the left hand side, if you transfer cos square theta to the right hand side, you can write 1 minus cos square theta over here. So in place of sine square theta, it can be substituted with 1 minus cos square theta. See, I am writing this. Minus, you already had cos square theta. So you see 1 minus cos square theta and minus cos square theta become minus 2 cos square theta. This is what they were asking us to prove, 1 minus 2 cos square theta.